So the question here is we only have so much cognitive bandwidth, both on the operator side and the ANSP side. And now we're asked to do tremendously more complex and larger volumes of operations. So how can we do that? Well, the only way to do that is through responsible, safe addition of human machine teaming and automation, not taking the human out, but to augment their capacity in significant ways.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovich from Radius Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Radius Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in.
Hey, welcome back, everyone. We hope you had a great end of summer. In this episode, we're absolutely delighted to welcome Jia Xu, CEO of SkyGrid. SkyGrid's mission is to create the world's most trusted airspace and operational integration platform, harnessing cutting-edge technology to enable safe, secure, and efficient autonomous flight for all. I first met Jia as we were preparing for our first episode with him, our 12th, back in April of 22. Now he's on our 99th episode in September of 25. If you haven't done so yet, go back and listen to Jia's first episode after listening to this one, and you'll hear an extraordinarily articulate, thoughtful, and informed person and industry leader. And now you get to hear this aviation thought leader express his views on what has changed the industry since 22, where we are today, and how he sees the future on a number of industry topics, but especially on the shared airspace and the future of autonomy. Many thanks to Jia for joining us, and to our guests, we hope you enjoy this and the previous episode from Jia Xu as you profitably innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Jia Xu is a proven leader in building at the intersection of electrified, autonomous, and accessible flight, currently serving as the CEO of SkyGrid, where he leads the organization towards a strategic goal of transforming the aviation sector through the integration of unmanned aircraft. Prior to SkyGrid, Jia worked as the CTO for unmanned aerial systems and urban air mobility at Honeywell Aerospace, where Jia led strategic technology and product development and engineering execution. Before joining Honeywell, Jia worked as a chief architect for UAM systems at Airbus, where he built operational architectures and data-driven business cases for UAM vehicles and networks. He also held leadership positions at the RAND Corporation, where he drove its advanced technology portfolio in AI, machine learning, UAS, and autonomy. On the air vehicle side, Jia worked on UAS design at General Atomics and taught aerodynamics as an adjunct lecturer at Stanford. Jia received his PhD in aeronautics and astronautics from Stanford. He also holds Master of Science degrees in aeronautics from Imperial College London and in international relations from the London School of Economics.
Jia, welcome back to the Vertical Space. It's really great to have you back.
It's fantastic to be back. The only regret that I have is that it's taken so long. And what an amazing couple of years it's been for the industry and for the vertical space and for Radius as well. I'm just really grateful for all the things that you do for the community here.
Yeah, and we're approaching our 100th episode. So time does fly.
The centennial. Yeah.
The centennial, that's right. Jia, have you changed your opinions on the things that very few in the industry agree with you on, some of your contrarian thoughts and bets?
It's actually probably changed a little bit since I will say aerospace is a really like large space, for lack of a better word. I started in this world on the aircraft design side, and then I went to Honeywell and did kind of all the onboard systems, safety critical systems. And that's how I got to know you guys in that context as well. And now at SkyGrid, we're much more focused on the operational side of autonomy and the operational side of airspace integration and air traffic management. So it's been a constant learning experience. And I think in that process, your view will necessarily evolve as you encounter new information and new ideas. Where it's evolved for me and where maybe there's a distinction is that I think when we think of autonomy, and I was one of these people, you really think very much of the aircraft as a closed entity, right? It has to have everything on board, be able to figure things out and act all of that. But one of the things that I've learned as I'm in this SkyGrid journey and what we're building to is that autonomy really extends beyond the aircraft because we exist in the national airspace, global airspace system. It is a complex system of systems. So there are lots of interactions. And part of the challenge of getting autonomous aircraft, in fact, arguably the biggest challenge of getting autonomous aircraft functioning is that they have to integrate into the national airspace. Per ICAO's directives, you cannot interfere with all the operation that's happening already, right? You have to be able to do this in a seamless way. And so that means this becomes a much bigger system level problem. You have everything, all the goodness, all the great technology on the aircraft, but you also need the offboard digital systems to provide you with things like surveillance, other kinds of data, decision support tools to integrate into that airspace. And then when you shift the responsibility a little, the air traffic management system increasingly has to take on this awesome task of integrating advanced aero mobility at lower altitude, at higher volumes, and with increasing level of automation. So if there's one thing that I want to call out as being somewhat of a different perspective, and the one that I have increasingly come to appreciate, is the importance of thinking of autonomy beyond just the vehicle. And I'll just caveat it. It's not like the industry doesn't recognize this. You've certainly had folks on from parts of the industry that has emphasized this, but I came from the airplane side. I'm passionate about airplanes as well. It's very easy to forget that, or perhaps not pay enough attention to it at times when you're in the knee deep in your flight test, right, in your composite build, and all of those kind of things.
Joe, where do you see the greatest bottlenecks in the system right now on the aircraft side or in the ecosystem side? And what hard problems remain to be solved on both ends of this
Yeah.
discussion?
I think if you'll go back to my last podcast, you'll hear a lot about the airplane side challenges. And some of those remain, right? Building very high integrity and availability and assurance avionics at the right price for onboard systems to bring it all together. Sensors, including critically reliable and certified detect and avoid systems, which, by the way, right, detect and avoid and surveillance and situational awareness is a critical component for integrating into the national airspace. It's really, I have to know what else is on the road at some level, right, to be able to operate, if to take a ground analogy. And that's an example where there are still critical things that we need to do on the ground side, right? Just airborne surveillance is better complemented probably with a ground-based view as well, since a lot of our radars, a lot of our assets are at the ground. And then airborne sensors also face challenges at lower altitude against clutter and other kinds of things. So that's one example where you can see very powerfully that ground-based infrastructure for all of the data that we can pull in and all of the compute that we can affect on the ground can integrate very synergistically with what's in the air.
And as you look back over the last 2 years,
Yeah.
how has the industry changed the most?
Yeah, that's a good question. I do think one of the elements that's interesting is there's now much more of a view toward operationalization, right? We see some of the early entrants on the AAM side start operating, some internationally, some increasingly moving also domestically with some of the policy tailwind that we're seeing, which we can talk a little bit as well. So there's much more of an emphasis now that we are really deep in the certification process for some of the eVTOL players. We have essentially some precedents and paradigms on how to certify and operate, let's say, UAS BevLOS right now that we have Part 108 and Part 146 in draft form at least out. That the industry, I think, as a whole is going to shift much more toward, okay, now we're building the airplanes, we're going to certification, we have to think about where to set up, we have to think about infrastructure, whether that's concrete or digital. We have to think about launching the first productive and valuable and impactful operations. So that's where I see the shift. That's where I see the tremendous excitement. The other aspect I think that we're seeing is temporal as well, right? We see the defense side of things continue to be a significant part of the industry, and a lot of advances are still made in that domain. What happened in terms of Ukraine over the last few years has really brought back the intensity of great power competition, of the intensity of regional wars, and the speed of military innovation on the autonomous side. And that, by the way, that's maybe the smalls that we're seeing, but around the world also we see a lot of advances on larger aircraft. So there's certainly, as much as there's advances obviously on the civil side in terms of autonomy, with all of us pushing in that direction, with companies like Wisk, which now SkyGrid is part of Wisk as a subsidiary. As much as there are the push on the civil side, the defense side continues to be a major driver in the pathway to autonomy. Perhaps that's not a change, but an emphasis of that perspective, right, in this era of very much renewed great power competition.
Joe, when you think back to 2022 when we were last together,
Yeah.
and you said now we're in the phase of operationalizing, for example, what's most different about the 3 years is so we're in more of an
Mhm.
operational phase.
Yeah.
Has anything surprised you in the last 3 years? Has the speed of innovation changed at all?
Yeah.
Or has the complexity of operationalizing and deployment changed as well?
Yeah, I would say that at some level, having spent a lot of time in aerospace, I know this is hard. So we've seen this, right? I've seen this firsthand at different places. So in a way, I am not surprised that the industry has taken the time, right? It takes to certify, to create the vehicles, the systems, and now increasingly also looking at ground systems and traffic management and all of these things. So in a way, I am not as surprised by that. What is I would say a positive surprise, and maybe this is a bias toward the very recent because it's clearest in my mind, but one positive surprise has been the attention and the emphasis on the policy side with the current administration, the Department of Transportation, et cetera, in terms of emphasizing the need for American leadership. And there are obviously then money and resources and material outcomes with that as well, right? So when we look at the brand new ATC system, the investment in that kind of infrastructure, tying together some aspects of airspace modernization with bringing new entrants into the airspace, as well as obviously the Part 146, Part 108 movement in terms of making BevLaws a pervasive and normalized part of our lives. And then the executive order as well in terms of pushing AAM forward, pushing integration and operationalization forward. And today we're seeing some movements as well on certification. This is all just happening in effect in real time. The pace of that has been somewhat surprising given all the things that the FAA and the USG have to do, right? And so when I go talk to the different kind of government entities as well as going on the Hill, I'm always kind of super impressed by how folks are focusing on these issues, on advanced aviation, on the impact on leadership, and the depth of their knowledge of this space and the willingness to ask, hey, how can we help? What do you sort of like this podcast, right? What do you see as the biggest challenges, and what can we do to overcome? So I'm really impressed by that. And maybe that sounds like I shouldn't be, but given what everybody has on their plate and everything that's happening, the fact that we have the attention to focus on this level of strategic competition and leadership is really important. And it's not perhaps surprising given what's happening elsewhere in the world, given what's happening in terms of aviation advances, let's say in China and elsewhere, there's definitely competition. And so now there's the response to that competition.
So I'm curious, what is your answer to that question when you go to the Hill and they ask, "How can we help?" What is the
Mhm.
next thing that, in your mind, they can do?
Yeah. So I think getting the legal, so there are many things, right? Getting the legal foundation for beyond visual line of sight out and doing so in such a way that is referencing data, that is referencing operational experience that the FAA has obtained through the Keysight and other activities was extremely positive. This was long coming, but for the longest time, I think elsewhere in the world, the sort of legal basis and policy basis for doing beyond visual lines of sight has at times been ahead of the United States. Whereas we are probably stronger in some ways of getting operationalized experience, sort of making the things that we can make work into the system, right? Basically, take the early wins, do incremental operations, learn from that experience, and then scaling that up and generalizing it through rulemaking. So it's that last bit that I think is important because now we have closed the loop. But the method by which that we have done it with the FAA in the United States, I think is also very important because it's very practical, it's grounded, and it's data driven at the end of the day. So closing that loop is really positive. I'm actually reminded of something that Joey Rios said on this podcast not that long ago, which is how can we make use of what we have today and make the existing operations that we have or the early operations that we have work. So I think closing that loop has validated in some ways the FAA's approach of using data-driven, kind of more industry-driven and performance-driven approaches to inform operations and then policy and regulation. So I'm really glad that that has come around, and we need to continue to do that. Associated with that, perhaps on the larger UAS and AAM scale, it's really the same thing. How do we get into early operations testing, maybe with parts of the airspace under modulated risks for large scale autonomous operations? How can we do that with today's airspace? How can we innovate both on the vehicle side, the ground infrastructure side, as well as the airspace regulation and construction side of things, right? Can we enable, let's say, more digital autonomous operations in a part of the national airspace that is still representative of the operations that's going to take place? How do we build those sandboxes, learn, and then inform with data and experience rulemaking? Like, how can we scale up the goodness of the key sites now to bigger aviation, inclusive of AAM, right? In that order. So I think that's really important. And what you see with the eVTOL pilot innovation and pilot programs, the EIPP, that the White House has mentioned, that others are pursuing, may give us opportunities to do just that. Those are, I think, are the kind of things that government can do, including making this a policy priority to push the industry forward.
Jia, I'm going to ask a question that's actually going to lead us into this discussion more about the shared airspace. It'd be interesting to get your views. You came from a world with Honeywell and the simplified vehicle operations where you had a lot of control over what's going to happen. Then you moved into with SkyGrid, an area where you don't control anything. You're moving into autonomy and you're
Yeah.
moving into helping to manage the vehicle movements in the airspace.
Yeah.
What's that been like for you? And how have both of those changed in the last couple of years? And then we want to hear your vision for this shared airspace.
Yeah, that's a cool question, Jim. I would expect nothing less. I would say, for one thing, coming from a company, I don't know, Honeywell Aerospace in their future, because they're splitting away, right? Of, I don't know, 40,000 people into a startup of, we're now about a little less than 100, is probably a big change in terms of where you sit in the industry pecking order, right? So that level of control even comes from that. But yes, you're right. The problem is, in a sense, much bigger, right? Because now it's, like I said earlier, it's that track of thinking about it more in terms of the airborne system. But obviously, Honeywell as a company has all the other businesses and they have a system view as well. But now it's much more the system bringing stakeholders along. There's the airspace. There are other players who do similar things as we do. There are air navigation service providers that we have to work with. There are rulemaking entities and constructs and regulators that we have to work with. So in some ways, the stakeholder community and the ecosystem has materially expanded. And so there's certainly an aspect of our work that is also influencing and leading the thought process. So we've issued at SkyGrid our concept of operations last year. We actually have some more work that's going to come in that space. Hopefully, folks will see that soon. So unlike a normal startup, let's say in Silicon Valley, we also write documents as one of our outputs, right? So that's one aspect where it's a little bit different. But there are also many other similarities. And what I mean by that is, even when we're building, let's say, avionics systems or onboard systems, one way that the industry has come together and make sure that these systems interoperate in a complex system of systems, which even includes aircraft, is things like standardization and the means by which we certify TSOs, right? All of these constructs that also takes industry consensus and a great deal of many stakeholders that has to get involved. So in that sense, it's actually not that different, because we also have to go to the same kind of standard organizations, figure out the same kind of interfaces, figure out the same kind of means of compliance in many ways. So that facet of aerospace pervades all of it. And as I think about what SkyGrid is trying to do in reference to something like SVO, which is how can I make the human operator a little bit more on the loop or over the loop even and have the machine do what it does best, right, in this human machine team. What we're trying to do in terms of airspace integration, decision support for the operator, as well as support for ANSPs, or doing delegated functions of airspace management, all of those things are essentially SVO now applied to the airspace and operational fleet level, right? So, because again, the question here is we only have so much cognitive bandwidth, both on the operator side and the ANSP side. And now we're asked to do tremendously more complex and larger volumes of operations. So, how can we do that? Well, the only way to do that is through responsible, safe addition of human machine teaming and automation, not taking the human out, but to augment their capacity in significant ways. And so, in that logic, the two are actually not terribly different. And I perceive that the learning at Honeywell about how do you deal with edge cases, how do you deal with the approval process, how do you deal with the human factors, there are actually a lot of similarities.
Jia, you mentioned Part 108. This is obviously a big milestone with the draft coming out recently. What are your high level thoughts on it?
Yeah. This is an interesting space for SkyGrid because we're not in the very small UAS world, right? We're not really in the segregated airspace UTM world. That's a different kind of a safety assurance, a different kind of a risk profile, and a different set of complexity. So even though in the UTM world you have words like strategic deconfliction, they mean very different things when you now have airports, vertiports, kind of lanes in the sky, and other kind of constrained resources and large aircraft that are safety critical. So in that respect, we're somewhat different worlds. But what Part 108 also specify are now larger, higher kinetic energy, highly assured UAS operations. That's of interest because at some point, I think even at low altitude, you are incurring air risk and ground risk that warrants better kinds of systems and better digital systems to support them. That's one touch point. Another touch point is the notion that now we will have normalized beyond visual line of sight operations. Robotic airplanes is now a thing, right, by definition. And so that's, I think, important for the whole industry. Even if we set that precedence at a small scale, that creates, again, more ways to generalize to the bigger scale as well. So 108 to me is significant in that way. And some of the precedent that it's setting in terms of right of way, in terms of the need for digital systems, is incredibly important for how we orient our thinking as an industry and how the FAA orients its thinking as a regulator. So I'll give you an example. Associated with the Part 108 document is also Part 146, which now talks about how do we regulate automatic data service providers, or ADSPs. That, for the first time, provides a name for entities like someday like SkyGrid, right, which provides digital services, decision support, and data to enable operations of all kinds of aircraft, inclusive of AAM. And so if you read Part 108, and this is like, I think, the prescience of the FAA and thinking ahead, they have category defined for UTM at low altitude, segregated airspace, lower risk operations, where you can, again, kind of self-declare that, hey, I'm good, guys, I'm good to go. And then they also like left out this higher category of service level 3 of saying, hey, this is Part 108 related, but we also want to define what ADSPs will look like for vehicles beyond Part 108 that are Part 135 operations and beyond. So we are going to leave this category in there. We are going to claim jurisdiction over it, that we can actually regulate it. And then we will create the environment by which we can foster the development of these systems in the future. So that's incredibly smart in my mind. And it creates this capacity for us to now think about how we, in more concrete ways, digitize operations for AAM, other aircraft, support high volume operations, and sort of find another way to further accelerate the pace of airspace digitization in the future. Because right now, it is possible that it's not just the FAA that's in this, right? You can actually approve higher assurance, approved operations that are safety critical, that are helping with decisions that have consequences in the NAS and for operators.
What's the difference when it's an unmanned aircraft that you are talking about when you say digitizing the airspace versus a manned aircraft? If you don't have a human in the loop,
Mm-hmm.
does it go really to a fundamental level of the difference of how a robotic system is transacting with these outside data feeds in an airspace system? And How do you discover the available data? How do you transact with it? How
Mhm.
do you secure those transactions? How do you provide all of the just the auditing and the compliance and the security and everything that you need in order to be able to let that happen in an automated way with these agents that are basically connecting with each other? It
Yeah.
Number one, is that what you're going after? And how do you see the fundamental differences there?
Well, Peter, I mean, you asked the question really well, and I feel like if those are the questions that move you, you should like work at SkyGrid. Like, I think that's the, if I may be so bold, but those are precisely the things that we wrestle with on a fairly regular basis. So,
Don't go,
the first
Peter.
thing,
Don't go.
I'm filling out the
um,
application.
the first dimension of that is you're right, right? When it's all more machine centric, a lot of the communications will be more machine to machine because we can do that. That's kind of the default state of things. And so now what that means is that data has to be more machine readable, right? So then you have a question of structured versus unstructured data. You have a question of interfaces and all of that. So that's a very like mechanical layer. When you think about the distribution of the systems and the composition of the system, you also realize that now there's kind of a ground station element, right? We have remotely supervised vehicles. In the case of Wisk, they're building one too many supervised vehicles. And there are others in the space that's doing very similar things. And so, in that way, the mediation now is through the ground station. You have machine to machine communications. You have potential for more efficient operations, more consistent operations as well. The kind of flip side on that is now the integrity of data is something that you have to worry about because you're now, yes, human is supervising, right? But what that implies is it implies a certain level of delegation to the machine to machine interaction and machine decision as well, because otherwise, if you're fully in the loop, there's no difference, right? So the fact that you're over the loop or on the loop implies a certain level of delegation. And as soon as you have that, you have to do the safety analysis, understand the safety case, and thereby understand the integrity level, the precision, and the sort of freshness temporally and resolution spatially of the data that is consistent with the operation that you're trying to undertake. So now the burden really shifts toward the data. And that just doesn't even just mean the reality of the data at the point of collection. It means the whole chain, right? The whole, how do you ensure the cyber assurance along the way that the data hasn't been tampered with? How do you utilize existing standards, some of which exist, to guarantee that transmission of the data that you haven't changed things and that it is still sufficiently fresh and up to date to enable the operation. So that whole chain of custody has to be thought about. So those are just some of the like first order things that you can think about. And lastly, as well as and Brendan Suarez and others on your podcast have talked about this as well, which is now that we have the data exchange being digital, now that we have the aircraft being digital, now that we have the airspace becoming more digital, what can we do to do the unlock? Because some of the flight operation paradigms and rules were developed at a time when just radars were becoming a thing, right? And everything was still voice communications. A lot of things were done manually. So then it becomes the next level of questions of as the systems are moving in this direction, and concurrently as the airspace is being more taxed with volume and complexity of operations, can we reconsider the rules of the game, right? What has to happen in the way that we operate to unlock that level of flexibility and unlock the potential of digital operations? So this is when you hear about digital flight rules or autonomous flight rules and this new category of thinking of what can we do on the rulemaking side to unlock the potential of digital operations as well.
What exactly does Part 106 say, and how does it explain ADSB? And by the way, this is so so confusing. They could have chosen an
Yeah,
acronym that
I,
doesn't so closely resemble ADSB, especially PMB being the voicing pair letters. But anyway,
yeah,
what exactly is the what used to be, I think, a third-party data service provider? Now they
mhm,
removed that third-party new element of it.
yeah,
And what are the levels of criticality of the data,
right,
and what really falls under that definition? What kind of
yeah.
data that the aircraft consumes is inside that definition? What falls outside, and what are the impacts
Mhm.
downstream on the robustness and certifiability of this data?
Yeah, yeah, yeah. I think some of these things are still being figured out, right? I would say caveat that it was Part 146 is kind of the foundation or framework, but many of the pieces inside are still left to be filled out in effect, right? And so what that means is that it has defined these categories of services. Level one being something that you can self-declare, right? Lower assurance, lower stakes. Level two, I think you kind of have to explain to the FAA what you did, right? Level three, which is what we're talking about as highly assured, potentially beyond 108, is where you have to show the means of compliance and what did you do, right, to actually get that. It's much more close to a traditional aircraft certification type construct.
What are some of the
So those,
examples for these three levels?
again, some of these have been defined. So you have on the UTM side things like elements of strategic deconfliction, intent sharing, conformance monitoring as some of the elements that's been defined in that category. But let's say if we want to do these things now for AAM vehicles, that would be totally different standards, and that yet still has to be defined. So the data and then some of the functionality to affect that, right? The logic and the decision support will look like that.
So
But
if a drone or if an
yeah.
aircraft is consuming weather data, that would probably
Mhm.
fall under level one data, I imagine.
I think it depends on the use case,
Depends.
right? But yeah, I mean, forecast data probably things that change quickly, right? They probably cannot be considered the highest level of assurance, right? Because you may not be able to get to that future state anyways, right? With clarity. But there may be other types of weather data that are collected hyperlocal sense that have more timeliness to it that could perhaps enable tactical functions as well that are higher assurance.
What is the
So
impact on the journey that this data and
mhm,
all of the stops along the way and the traditional data centers that might be the
mhm,
intermediaries today? Are the regulations, especially if you're level two or level three type of data,
mhm.
will that require a different architecture for data centers?
Yeah, that's an interesting question. And we do think that the higher level of requirement is going to impose more strict cyber assurance integrity requirements. It will involve the necessary system level thinking about architecture, about redundancy, and about the assurance around it. It also has enterprise implications because 146 is not per se about the product. It's really about the entity that is going to operate this, right? And so there's a corporate dimension of your safety management system, quality management system, your cyber assurance approach that is about the product, but also extends beyond the product because it's the totality of all of that work that creates the necessary level of safety and assurance that we need. So in a way, you're right. It's the mechanism of the transformation and delivery of that data, and we have standards for that. And some yet to be developed. It is also about the system as a whole and the architecture, as you've talked about, and extend beyond the system to probably embrace the whole enterprise as well.
Are you guys planning on submitting comments for 108? And so, can you give us a hint as to what kind of comments you would want to provide?
Yeah, for the folks who are listening on the 146 team, one thing is I just really I support the future orientation that we talked about in the 146 approach. So I don't know if like support is a comment that we can make, but I support that aspect of it. I also support the clarity of making this kind of digital services a priority for regulation. There's even a paragraph in there where the FAA talks at length about the authority that it has to regulate this category of third-party services, which was very, I think, was very well done and very like structured. Where they talked about, well, Congress through reauthorization gave us the imperative to regulate third-party services, so we claim authority from that. The FAA has historically had the precedent of regulating air agencies, which includes certain training schools, and that gives them the ability to regulate third-party services that have safety implications. So I think that's very positive to have clear authority to do this because up until 146, it's not clear that the FAA has the authority to do this, right? To regulate things beyond aircraft certification, engine certification, all of that. I think one comment that we'll probably make related to this is now that we have the framework in place, how can we accelerate the development of these component kind of means of compliance or service definitions that's needed to then go approve high assurance services like, let's say, strategic and tactical deconfliction for bigger aircraft. So the FAA has defined the construct of SPSOs, which are like TSOs, sorry, too many acronyms, like TSOs, right? So like what used to regulate a box or LRU on an airplane, now regulating a digital service. Like how cool is that, right? That's like a new paradigm. So in our mind, it's great, let's accelerate the next phase, right? So there's a problem with giving an industry a bone, right? They'll want the whole world. But for us, that's kind of where the actual work is going to have to happen now with the FAA, with the standard bodies, and with the industry writ large. Which, by the way, Luca, I forgot to mention, I'm really glad that ADSP is spelled without the dash, because if that were the case, we would be in a world of hurt.
Agreed.
Joe, when you walked into SkyGrid, you became aware of the airspace, the
Yeah.
complexity of the airspace.
I was vaguely aware before. I wouldn't say that I was
Yeah.
totally unaware, but yeah.
Well, yeah, sorry. Well, you're making your business now in the shared airspace.
Yeah. Mhm.
And you must have thought this is so much more complex than most people realize. You may have
Mhm.
already realized it. Talk a little bit about the recent past of the shared airspace,
Right.
where we are today, and
Mhm.
the relatively near future of the shared airspace,
Mhm.
and educate our listeners for those who may not be aware of the complexities, the challenges, and the opportunities.
Got it. Yeah, first, I would, even before we start, reference some of the experts that spoken on this that probably spoke much more credibly. Again, Joey Rios spoke a little bit about the history of the airspace. Brendan, again, I hate to always bring him up as well, but he, through multiple discussions you've had, I couldn't quote, hey, refer back to episode number 26, right? But like, that's the kind of thing they've also talked about some of this. But in a nutshell, right, the airspace has evolved in large measure with, like many things, other parts of aviation, with a safety mindset, right? How do we increase safety? How do we kind of not let go the lessons that's paid in blood, right? So some of the biggest advances in airspace control, air traffic control, which really boils to a large degree into separation management, making sure the aircraft stay out of each other's way. A lot of them come from accidents, right? Mid-air collisions, including the one that happened over the Grand Canyon that kind of prompted the shift toward IFR operations backed by radar, right? So the last great innovation really was around the time of radar, which was a long time ago, right? Of course, the foundational innovation, you can certainly count things like ADSP, which has been significant, as well as more recent evolutions in that picture. But essentially, we went from VFR, which is pilot doing a lot of things, having the separation responsibilities there, being only able to fly in visual meteorological conditions, into this IFR construct where now the responsibility for separation and safe operations is divided, right, between the pilot and air traffic control. And in many places, air traffic control has positive control, so they control the aircraft, right? They essentially tell you where to go. And that has historically created this tension in a way that VFR is somewhat more flexible, but IFR is more provides you more access, right, in terms of flying under different kinds of meteorological conditions and in different kinds of airspaces, including in airspaces that where that requirement of equipage and IFR control is stronger. So that's roughly the history in a nutshell of how the airspace has evolved in the US, and of course elsewhere in the world the story is quite similar and analogous. Where we're going since next gen and then since the introduction of ADSB, which has created a more information rich environment in the airspace, although it's not perhaps at the highest level of assurance because ADSB can be spoofed, they could be installed incorrectly, they're dependent. You don't have to install it if your airplane is really, really old. So we still have a digitized, perhaps partially digitized airspace in that way. The other thing that's kind of interesting, maybe the more plain spoken way of explaining it is in this age of like chat GPT or Claude, and I don't even want to say cell phone. Cell phone was many ages ago, right? Like whatever it is that the kids have now. In this age, the common understanding of air traffic control is probably not what it is actually, right? Which is there's a lot of manual processes, it's mediated by voice communication. It isn't very strategic, it's fairly tactical. Intent isn't really shared, isn't really capitalized to optimize capacity. So in a way, where I think we're going with the airspace is ideally this place where if you ask someone on the street, their expectation of the airspace, which is probably like some level of coordination, right? Digital communication of information, people sharing their intent, and then optimizing the trajectories and access to different precious resources using machine intelligence, augmenting people, and being very strategic, right? Making use of all that information to think ahead on how we reduce delay, improve environmental outcomes, and all of those things. So, in a way, it's like when you ask someone on the street, like, how does the airspace world, they probably wouldn't tell you, hey, like, we may have like strip charts and paper shifting on the table, and we might step over each other when we try to communicate over VFR, right? Like, they probably wouldn't give you that read. So how do we get to that more common read, commonsensical version of the airspace, so to speak?
So when you speak to the person on the street, this would be their impressions and this would be their viewpoint, and it would all make sense. But when you ask the person in the tower,
Hmm.
you probably got to a sense of reality of, oh gosh, this
Yeah,
is how it works today. And we've
correct.
all heard about the manual, we've heard about the flight strips. It's a very manual process for a lot of valid reasons. So when you stepped into this world
Mhm.
of shared airspace today, that it's easy to express an articulate vision of the way it should be, but to be able to articulate how do we get from where we
Mhm.
are, which is a very safe space
Correct.
with significant separation, with a lot of manual processes and
Yeah.
old equipment, how do we get to that next step forward with all the things flying they're going to be flying in the coming
Mhm.
months and years? What's your vision to get from where we are to this efficient, digitized, shared airspace?
Yeah. I I think that's absolutely right, and I should obviously caveat with what I say was this is an extremely safe system, so that actually makes any kind of change, rightfully so, having to really earn its place, right? That is to say, the impedance is necessarily high because we have a system that works really well, and the consequences of failure is dramatic, right? As we've seen recently with what happened around DCA in terms of the in-flight collision, and also in terms of some of the impacts, if not material impact, but certainly psychological impact to the controllers of communication outages and things of that nature. So there are definitely things to be had about maintaining safety. That's really the primary objective of doing all of this. And so just in the same reckoning too, it's like, what can we do to actually then improve safety? That may be the best way into this, right? Rather than to say, hey, I'm really in this for, let's say, efficiency. It's like, how can I make this safer to begin with? This is much the same story as SVO, because when you make a statement of, hey, I want to do SVO principally because I want to increase efficiency or unit economics, yes, that's true. There are elements of that, but it would be much more powerful if those objectives are directly aligned with improving the safety outcome, right? If I can say, let's create an SVO system that will drive accidents incrementally or dramatically towards zero, I would have a much better case than, hey, let's just do this to make sure our like bottom line is better, right? So I think in the same way in the airspace, we have to make safety the number one priority. So what can we introduce that will be safe? I think the other tailwind that we have in this regard and the opportunity to do this is kind of in this era where we have Part 108, Part 146, that they're not exactly today for this application, right? They're talking about segregated airspace. But guess what? That's an environment where we can learn quite a bit about how to safely operate some of these new concepts, right, of strategic and tactical and digital conflict resolution, and then learn from that experience, but then incorporate all of the constraints and design features that is needed to operate in shared airspace to get to that end goal. Another element on the pathway from here to there is to think about all the technology, all the layers of the stack to operate efficiently, and also to build the assurance by design and by experience that's needed to make the transition. So, what I mean for that is you have to be able to mobilize the same kind of proven aerospace design assurance paradigms. How do I do the safety case? How do I do design assurance for my software? How do I do all of those things to ensure that I have confidence in that I am delivering the outcome, right? In that I am producing no harmful effect and the system is functioning as intended. So that's another aspect to get from here to there, is to leverage what we already know in the aerospace domain to create assurance and to translate it into the ATM space. Because one of the interesting things there too is that up until very recently, no one has said this is how you certified an ATM system, right? The European Union with EASA has actually done that, I think earlier this year, where they've said, okay, this is how we're going to certify an ATM system, right? It's going to have attributes that look similar to how you certify an aircraft system. And so that is yet another path, right, where this space now becomes more normalized, more regularized to allow for third parties to build composable systems into it. And that could then enhance the speed of innovation. From a SkyGrid perspective, this makes sense because it's it gives us an opportunity to build a coherent product that helps the operators today, that may help ANSPs tomorrow in this advanced air mobility space where the traffic is potentially significant, the low altitude coverage and information space needs to be upgauged, and then the level of decision support and logic and of strategic and tactical deconflictions have to be that much more capable, right, to alleviate the workload that would otherwise be imposed on the air traffic controller. So it creates the need and the sandbox for that innovation, which we can then think about how do we think about using this for other segments of aviation as well. That's the pathway in my mind.
You mentioned improvements in safety. What are some of the near-term levers that you see that the industry can pull on to effectively increase safety?
Yeah, so certainly better domain awareness of all the having a fused common operating picture. That's with all of the intent of the different actors as best as it can be characterized. That's one thing that could improve safety and efficiency, right? If we know what everybody is trying to do, we have a more credible and higher assurance view of that operating environment, both the natural environment and the traffic environment. That's going to deliver dividends because we can be smarter about our strategic and tactical deconfliction there. Air domain awareness in the way of better surveillance, this is actually one of the critical needs for autonomous aviation. And having that domain awareness of traffic delivered at high assurance and low latency is going to help you with rotorcraft operation as well, with other kind of operations where you're exposed to the low altitude coverage gap. And so I think that brings another element here is a lot of the things that we're doing for aircraft to operate more autonomously in terms of lifting the quality of the data, the assurance of the processing, and all of this is going to pay dividends on crewed aircraft as well. And when you think about SVO and the continuity of automation from SVO to this more autonomous construct, it's actually not that different because as soon as you sort of say, I'm going to allow people to supervise, it implies a level of delegation of responsibilities. And in an SVO context, when you do the safety, you can very quickly come to a place that says, hey, the system doesn't look too different from a system that it can behave autonomously because what if I have pilot incapacitation, right? And I have single pilot operations. How do I even deal with that? That means the system has to be able to operate with continuity on its own or with the help of an offboard remote control center or ground station, for example. So in that world, what we learn in autonomy is going to help with things like SVO, which in turn I think is going to help all future operations, which become a little bit more automated. And that just means that machines may have a bigger role. And so if we conceive of aviation as moving in a direction where the human machine team's role is always being adjusted, right? Maybe the machine do a little more of the mundane and the human does more strategic and he or she needs to do more and more strategic over time, then we have to figure out the pathway to autonomy no matter what.
What part of this tech stack is the most immature today and perhaps an opportunity for startups to go and innovate?
One of the biggest gaps still is people like to say the conspicuity question, right? I think that's still one of the most important things is to know where everybody is and to do that with some level of integrity and credibility. And this is on the sensor side. This is on the digital infrastructure side, which is being addressed by things like 146 and by things that we're trying to do. But the sensor gap and the emitter transmitter gap is still there, right? This is a tough problem. And I think we should throw more attention at it because e-conspicuity is an end state. It's like saying, I want to know where everybody is, right? But it's very hard to get to. So like, yes, we have applied a label to the problem, but we do need to throw some brain power at solving it. Some of the other, let's say, cases, weather is always going to be hard, right? Understanding the environment for that. There are things obviously that you can do to be robust to weather, right? You can design that in. But understanding weather and the environment that we're in, especially as the intensity of certain weather becomes more significant over time, is going to be important still. And I think, the problem that you said earlier, which is the back-end system, how do we host all of this stack? How do we think about the interconnectivity, the communication, the cloud stack to do this? That warrants some more thinking as well, because now kind of when you're thinking about the engineering sense, right, the balance of availability, cost, determinism, redundancy, all of that is going to maybe get reshaped, right? When you need to deliver something that is more assured over this kind of cloud environment. And there are many standards and definitions that are still open there.
I want to learn a little more on your thoughts on weather data for these types of craft. It occurs to me that when you're flying an airplane through the airspace
Mhm.
system,
Yeah.
especially in parts of the country where you have thunderstorms in the afternoon and you have that type of weather, so much of the decision making comes from what you see with your own eyes looking
Mhm.
around. It's not from the 12-minute old radar information
Mhm.
that you might have or the 1 hour old terminal conditions at the airport. And so the way the airspace system with respect to weather works today, the weather data that we have is sufficient, provided that we are also using our own immediate sensing of the weather conditions around us, right? Oh, there's a cell right over there. I should
Yeah.
avoid that, right? But when you move into these networks of unmanned aircraft and drones, how are they going to get the level of fidelity and weather data that they need in order to be
Mhm.
as safe? It's not going to
Yeah.
be the same weather data that we have today. It's got to be either you have to have dedicated weather sensing on board the aircraft, or you have to have a whole different level of fidelity in the weather data, I would think, that is being sent to that aircraft.
I agree. I mean, I think there's definitely a need to up level the resolution spatially and temporally, as well as the integrity of that data for certain applications. I think the tricky part is going to be what can you actually achieve, right? What is
Yeah.
good enough, right? Historically, you're right. There is an implicit understanding, as with many of these transitions from piloted to autonomous, is that the pilot, right, the Mark One plus the very efficient neural computer that is there is doing all of this like calculations, all of this decision making, and we say that's kind of effectively DAO A today, right? Very highly assured, even though perhaps it's unmeasurable what that really means. So the you're right. There's definitely this question of like, how do I replace that situational awareness and closed loop high quality decision making of a trained pilot when I have an autonomous aircraft? So yes, onboard sensors may have to get better. Maybe more like onboard radars are needed. Another way is to understand the total safety case of your operations, and that has to account for the variability of the weather, the length of your operations. Right? Are you doing an eVTOL flight versus a cross-country flight? The quality of your in situ sensors and the assurance of the data that you're getting from there, as well as how can you appropriately use forecasted data. Maybe it's even forecasted data that's linked to with some real-time data that's anchored in that. So maybe you can't maybe you can develop a better forecast, but maybe you can't use that for, let's say, real-time tactical decision, but you can plan better and reach a high level of efficiency, at least in terms of your go no go decision. So weather, I think, is both interesting and tricky because of the fact that it is, at the end of the day, hard to pin it completely down, right? So you still have to operate with some level of uncertainty. And then at the same time, there's always this desire and need to do better, right? So that's what makes it even more complex over this the question of like going from piloted to autonomous.
Joe, you've talked about the future of aviation as autonomous. Where are we today? How does autonomy play out in the next couple of years? I would assume with Whisk, it's absolutely necessary, right?
Mhm.
They're all in on autonomy. Yeah,
That's
give
right.
a little bit of an overview for our listeners.
Right.
Where are we and where do you envision it to be in what time frame?
Giving a time frame is always going to be hard because who knows? Maybe I'll come back on in 2 years and then we'll have a fact check on my predictions. But the I think the near term, yes, you're right. I think it's very exciting in terms of us getting civil autonomy off the ground, probably in the AAM space first. There's also obviously, as you see, efforts in just rotorcraft, all kinds of other aircraft, conventional takeoff and landing aircraft getting more into an autonomy in there. And oftentimes it's this tension between autonomous, as in I have someone on the ground supervising, versus more SVO constructs. But as I've mentioned, that's the continuity. So I expect that continuity to continue to advance and getting to operationalization. So the really exciting part now is like entities like SkyGrid coming in and figuring out, well, how now that we have the construct on board, how do we make that fit in the construct of the national airspace, and how then can we perhaps refactor that technology stack of what's on board, what's off board, what's in the cloud to affect the best possible operational efficiency and operational safety. And so that's, I think, very exciting. To me, it's also about keeping our ears to the ground of learning what's going to happen now that we have potentially large scale US operations in segregated airspace. What can we learn from that experience, given that's where a lot of aerial robotics will happen at scale as well? So even though to me that's a somewhat different space, I do want to see the advances there, right? And learn from that experience. And knowing that there will be caveats for scaling it to bigger airplanes, but it's something to definitely keep watch on. And of course, on the military side, this is all going to move very, very fast. And so companies that can do both could also benefit from that acceleration, no doubt. It's interesting. Someone at Boeing once said something that I found really, really interesting and really tactile, right? Because it's something I've tried to explain in many words, many more words before. But he basically said like civil autonomy is kind of like driving cross country safely, right? Like military autonomy is kind of like driving across country safely and robbing three banks along the way. It's like a different level of assurance and expectation of risk, but also then a different level of complexity in a sense. So I think that's another space definitely to keep watch of.
When looked through that lens of definition of autonomy and the civilian and the military context, what's your assessment of the efforts of well-known firms that are operating in this space, whether it's Reliable or X-Wing, Joby, Whisk, Aurora? What major milestones impressed you? What system bottlenecks remain?
Yeah, I think the biggest thing will be getting operational validation, right? Getting into real operations, in our case, from point A to B without robbing banks, right? That's really step number one and the most important milestone. And that entails a measure of like, how do I access the airspace, right? How do I do the coordination? How do I figure out the letter of agreements with the air traffic authority locally to start operating? So that to me is the most impressive milestones, and that's what we as an industry have to strive toward. Many of the other pieces, a lot of the technologies are in place. There are definitely some corner cases and some parts of the space that are hard. I won't really enumerate all of them, but there are definitely some that are challenging. But when you look at it, people are building the pieces, they are integrating the systems, they are having productive conversations with the FAA. There is going to be more attention, I think, in the near future toward the operational side of the rulemaking equation of how do we accommodate autonomous aircraft in a more systematic way in the NAS. But really, for me, the milestone is to get to that point A to B autonomous operations on a regular basis with one of these entrants and with the right digital system to enable that.
How close are either of those players or just industry broadly coming to those milestones?
I think we're getting there. We are certainly from a SkyGrid perspective, we are building with the urgency of being there in the next few years.
Jia, I was excited for SkyGrid when I saw that you were joining. You're an extraordinarily capable guy. Let's say you were interviewing with SkyGrid, and your first question was, what problem are we solving? Or do we plan to solve? What would be the answer?
We are in the business of opening the sky for autonomous flight. That for us is problem number one. How do you solve for airspace integration and the safe integration of autonomous aircraft into the airspace? And we think that problem is very important because, again, we have lots of players building aircraft. They're all toward increasing automation and autonomy, but there is this gap, right? And I was even at the Honeywell Summit, the last one that we were all at. I think I was on the stage with a bunch of CEOs from different companies and C-suites, and my last question was kind of like, well, what keeps you up at night, right? At the end of the day, and they all said airspace integration or air traffic management for AAM, and so maybe I got a hint out of that, right, in my actual interview with SkyGrid. So that's how we see the world over here in Austin.
And what's the closest analog with today's system that
Mhm.
would be corollary to what you're planning to do for autonomy?
That's a really interesting question. I think there are a couple things, right? In terms of the design approach, in terms of how we have to think about autonomy as a system and safety assurance and all of that, we draw inspiration from the aviation world, from even things like SVO, right? How do we do the allocation of responsibility? How do we do the safety case? How do we think about system design and redundancy and all of that? From the perspective of airspace organization, I think a facile analogy is this idea of like UTM, right? Digitization. And UTM is digitally like native at low altitude because that was a space that's kind of open before, right? It's not highly utilized, but now that we have drones that can use it. So PK and NASA had this instinct of doing this kind of a revolutionary step at low altitude, and it's possible because it's essentially a kind of a white space there. And even then, it's entailed a lot of challenges, right? It's not a complete white space in that we still have to worry about transit by crewed aircraft or other aircraft that are not on the UTM system at low altitude. So it definitely still issues there. But on the whole, that level of digitization of human machine teaming, of machine based thinking, we do draw inspiration from that, even though we understand that the system has to be fundamentally different in many ways. And that kind of going back to the very earlier conversation, that part of this conversation, when you want to do that in shared airspace, it is a much more complex environment with many more stakeholders, right? So it's not like we can just impose this. We don't have like that power or authority. We have to rather say, how can we enable the operators today, right? How can we make their jobs easier and better? How can we make it safer? And then how can we then, on the other side, kind of act as a broker and help ANSPs, right? Can we build systems to help them reduce their workload and actually be able to accommodate the AEM world that's to come? So that's where I think the analogy is both helpful, but also then breaks down because we have to do what is in effect a much more ambitious thing.
Do you see playing a role in the below 400-foot airspace area, playing like a UTM type role as in scope for what you guys are going to do? I mean, it seems like there's an argument that you could make in favor of that because there may well be a very high volume of unmanned flight hours being accumulated with those types of aircraft on those types of missions that could be interesting. But
Yeah.
how do you weigh that as
Yeah.
part of your path and your roadmap?
Right. I mean, that's a fair question. It's definitely one that we have thought about. One side, I think, is it. Some of it may naturally happen in the sense of like parts of Part 108 operation will probably be increasingly like larger, again, higher risk vehicles. One might ask that even if they were to operate initially, let's say in a more segregated airspace environment, what is then the safety level required, right? The very just because they're operating at lower altitude doesn't mean that they don't impose quite a bit of risks, and then perhaps you actually need a higher assurance system to deal with that. The other side of it too is that they might quickly realize too that they need to actually operate potentially a more integrated environment or transit through integrated environment such that they could achieve the operational flexibility that they want. So again, in that case, it might push them into the boundaries of what SkyGrid is trying to do. I think that has to be balanced too by what do we think is the long term viability of UTM, because it's in effect in an environment where there's less assurance requirements. So in principle, more players could do it, and then you have certain operators of, let's say, large fleets of drones that will just build their own UTM system as well. So there's a kind of question of how much of a moat can you create with a purely UTM solution versus one that, in our mind, is like you want to go to a place with more stakes, which is probably where you're going to create more value.
Jia, describe the major phases in the life of SkyGrid and how it has evolved and what strategic insight led to these pivots.
Mm-hmm.
And correct me if I'm wrong, but I think the early focus back in 2018, I think it was, as a joint venture between Boeing and Spark Ignition, it was focus on UTM, command and control tools for small
Mm-hmm.
UAS systems. And that was done
Right.
via mobile mission planning apps. And
Yeah.
then there was a transition to high assurance, enterprise grade products, and then further expanding from there into even higher integrity services. So, what's been behind the scenes? I know this you came
Mm-hmm.
after a lot of these
Right.
decisions, but in retrospect, what
Right.
drove some of these major inflection points in the trajectory of the company?
Part of it is just, I think, is emblematic of the entire US and drone industry, was that folks in a way thought BEV laws and all of this would arrive faster. And so when SkyGrid was formed, there was a view that this was just around the corner. Let's go like all full speed right into kind of this UTM world. But kind of the issue that we just discussed came front and center, which is, well, If we're doing that, then there has to be like a long-term business model here, like a moat in it. And it wasn't very clear at the time that it was apparent. And we've seen this with the likes of air maps and others, right, in terms of the UTM space as well. So I think that's the kind of macro. Internally, some of the alignment was also driven by the fact that at the end of the day, there's a Boeing stake in this. There's a view toward bigger things, whether it's kind of the Wisk side of the world or what can Boeing do to inform kind of the development of the future airspace, right? You might remember as well that around that time when I was actually at Airbus on the other side, that Boeing and Airbus got together and wrote a vision for the future airspace that talked about a lot about digitization, AFR like concepts. And it was a kind of a trend-setting piece of document for the industry where, again, these two historic rivals came together and outlined a coherent vision for the future airspace. So some of those motivations came from that as well, that for this to support this holistic vision of autonomy at Boeing that includes the entities like Wisk and also what Boeing is doing, that we need to orient toward bigger things, more ambitious things. And I've since had shaping on that strategy in my role, but you're right. Some of that started before I even got here, right? Fabrice Kunze, who led the company for a while, who you may know, who's now at Aviation, did a lot of that work on the ground as well.
Do you mind giving us an overview of the products that
Mhm.
SkyGrid is offering to customers and who are those customers?
Yeah. So essentially, you can think of our products as there's a family of product for the operators, or like your AEM operators and your fleet operators, and we provide common operating pictures and decision support tools to help them better integrate into the airspace, improve their operations. And some of those services include the better data, right? The better decision support tools, surveillance capabilities. We provide a high integrity, high assurance surveillance data feed with partners that is going to help the integration of autonomous aircraft. Many of those same services could also operate on the air navigation service provider side, either as SkyGrid as an ADSP that's providing some of these services directly, where it's possible, like in the United States, or internationally, we would actually provide these services to ANSPs who want to integrate AEM and who may someday want to provide these services for other types of aircraft as well. So that's kind of generally how we see the market. We have deployed with AEM and operators of that nature. We have customers in kind of the existing operations space as well. And we hope to be able to announce some other ones actually very soon. That's more kind of the other parts of the business space that we're trying to address. So look to announcements very soon in those regards.
Joe, how often do you hear about Boeing ATM as something similar to what you're doing within the halls
Yeah.
of Boeing,
Yeah.
either in a positive way or less positive?
Not perhaps often enough, but I think it's important for us to understand some of this. I don't see it as a direct precedence in many ways, but I'll just give you a sense. I think Boeing ATM was like a thing in the early 2000s. So at that time, I was probably still in college, right? So for me, it's a bit of history there. But what I would say, what the continuity there is that Boeing as a company is very strategic in its view of the airspace. And the earlier reference point that I had was the joint white paper with Airbus on the future airspace, and even our ConOps that we've released as SkyGrid, the joint ConOps with Boeing and Wisk on their operations. Many of those things highlight kind of like this importance of airspace, of knowing that Boeing is an important player in commercial aviation, but for that industry to thrive, we have to have an airspace that is future proof, that is safe, and that will support volume operations. So it's a very strategic pillar of how Boeing thinks about the ecosystem and thinks about their long-term commercial aviation strategy. So irrespective of whether or not Boeing has a business unit that is there to kind of build into ATM, the importance of airspace can never be overstated within the Boeing context. And so if there's one shared thread, it is that SkyGrid, along with other parts of Boeing, are working to enable the operations of the now, as well as the sandbox for AAM and how that kind of informs bigger airspace. But also, we have a vision of how can we, in some ways, contribute to the public good of thinking about how can the future airspace evolve to accommodate all entrants, new entrants, traditional entrants, what can we do? What has to happen to enable this more strategic, more efficient, and safer and smarter operation of tomorrow in the airspace?
Back to the product and the common operating picture, how does one build a certified high assurance version of that? Obviously, there's a lot of products along that spectrum from
Mhm.
some common apps on mobile phones to the things
Right.
that Avionics is doing or Vantis is doing. Where does SkyGrid fit along that spectrum? And what really, when you get into the weeds, into the
Mhm.
details, how does that work?
Yeah. I would say, without getting into too much details, one of the biggest things is the starting point of positioning of where do you see yourself, right? Do you want to kind of start at the UTM level and move upwards, or do you want to be at the SkyGrid starting at the ADSP for AAM for short aviation and moving from there, right? Because I think there's always this sense of disrupting from below, but I think positioning also matters. So for us, being that digital backbone for AEM is important because it gives us the safety culture and the orientation to the product that I think is then required to tackle the bigger problems in the NAS and integrated operations. So I can say that what it means in terms of safety is to really think the whole system engineering side of things, understand what it takes to assure the product, writing the software in the right way, and investing in the kind of enterprise quality management, safety management that is required to qualify you as a high assurance ADSP player. I think that's a really big piece of it. And then investing in things like modeling and simulation and other assurance tools to make sure that the system that you're building can actually enable autonomous operations and can actually enable the kind of delegated operational authority when you have this human machine team. So I think it's been said by others in this space as well. The emphasis here isn't necessarily on newfangled algorithms. It's really on the system engineering that it takes to bring an assured market, a product to the market.
And when you're thinking about the market that you will go and address and serve, what are the segments that will most likely want to adopt or be required to adopt this high level of assurance, as opposed to a lot of the UAS services that
Mhm.
are operating now, which don't really use that?
Mhm. So certainly, when we think about anything that has passengers on board, right, and then large aircraft that have significant air and ground risks, where we think there's going to be stakes, higher risk operations, perhaps over more populated environments, that's going to drive probably your safety case toward higher assurance. And even those are kind of in the AEM space. But I also think that as we build better and better systems, we'll want to figure out ways of playing roles in the modernization of the NAS. Can we deliver piece and parcels of these systems into ATM systems? Can we help some of those existing operations to be smarter and more efficient once we have a coherent product in this kind of low altitude AEM space?
Joe, when you were at Honeywell, I presented a question to you. If you were speaking to the CEO of Honeywell and he was going to go speak to a group of investors, how would he express what you guys were doing? And
Mhm.
you said something like, well, I just spoke to the CEO of Honeywell, and here's what he would say. Let's say Kelly, your CEO,
Mhm.
was talking to Brian, who used to run Whisk, and he's
Yeah.
saying, boy, there's a lot going on with Boeing right now, which is in a very positive
Mhm.
way.
Yeah.
But this is a really strategic opportunity for us. How is what SkyGrid is doing going to help us in the near term value to our shareholders?
Boy, I mean, it's like it's the time of the budgeting cycle right now, Jim. Like this is a really good conversation to have. The biggest thing here is that Boeing is in a place where you're right. I think it's trending very positively. There's a new energy. There's a renewed focus on getting this done, right? And full support across the board for Kelly and what his team is doing, and for what Brian is doing vis-a-vis the commercial side of the business. I would say the biggest thing is once we're on track again for Boeing, it's really thinking about then what is the next aircraft? What is the aircraft after the next, right? What is then we got the basics done, which is not simple, which is very hard. We get the production volumes up, we recenter the business, then the question will return, well, what is next, right? And that's where companies like SkyGrid and Whisk play a role. Like what are we doing in terms of opening up a white space in aviation? And that's AM in the broad sense, right, of autonomous aircraft of different sizes, like you mentioned, everything from the upper end of 108 to other kinds of aircraft. And I think the advantage of SkyGrid there is we have the ability to support different kind of operations, different kind of actors in the space. So that's a white space that I will want to conquer for the Boeing company, right, in a sense, and also provide this kind of a new airspace construct for the world. The other side of it too is when we think about technologies for future aircraft, what is the right combination of offboard, onboard systems, digital infrastructure versus onboard systems to enable increasingly autonomous operations? And wouldn't you want to be able to then have a coherent view of that at the product level, but then having that coherent view with the regulators and with the folks who are setting the rules about the future airspace so that you can best anticipate and create value in that future state as well. So, I mean, Kelly, if you're listening, that's kind of me pouring my heart out.
That's great. That's very articulate. That's great.
Of course he's listening. What are you talking about?
Right, I know, right? This is a vertical space, guys.
Jia, anything that you would want to leave the audience with?
Just that as we continue to innovate in the vertical space, I think we want to keep in mind that the kind of scope of innovation extends beyond the aircraft. And it goes into the digitization of the system of systems, the operations, and the airspace. And if you're innovating here, we are here too. So I'd love to be able to join hands with you guys.
Perfect. Well, Jia, thank you very much for your time. Always a pleasure to speak with you. Thank you for coming back, and thank you for being a fan of the podcast.
Yeah, absolutely. Always. Once and always. Yeah.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and/or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.